All right, Angela, go on ahead.
All right. Hello, everyone. I'm Angela Lane, the Security Project Manager here at Solis Security, and today me and the team are talking about successful customer engagements using the OWASP Mobile Application Security Verification Standard, which is a long way to say we tested some mobile apps and we're going to share what we learned through that process. So clearly I'm the Security Project Manager, Angela, Mark, Sam, and John, all part of the team, and our handler or CISO, Brian Brown, who's also here. You guys have also, I'm sure, heard him speak. All right, this is just to show some statistics surrounding mobile applications. As mobile applications grow and become more and more popular, obviously the security aspect, security testing around them grows as well. So it'll be interesting to share what we've learned in our process and keep the conversation around this moving. And with that, here's some examples of potential threats you may see with mobile applications. Obviously, losing your mobile device is a security concern that we might all be familiar with, but there's some others here, such as third-party app stores, third-party applications, repackaged mobile applications. There's vulnerabilities and threats here that we might not always be aware of. So it's important to be apprised of this information and knowledge. As we've seen in the previous slide, the use of mobile application grows and grows. Here's the top 10 mobile risks from 2016 that OWASP put out. For those of us familiar with web application risks, it's kind of important to shift focus into what we're seeing on the mobile side, what kind of risks are present there as well.
So this is Mark Spear. So when we test this out, we're very used to the web application testing frameworks. I know there's the OWASP testing guide, there's the web site testing guide, there's the OWASP top 10 methodology, and there's of course the application security and verification standard. These documents are actually for the mobile kept oddly very up to date. And so what we use to test is this as kind of the methodology of what we're going to test. And so, you can see over here that there's a big number 4 here at the top right. Everything's rated on a 1 to 5 scale as far as how secure it is. And you can scope this however you want, but that nice spider graph that you're seeing shows the different domains of testing. And some of them are similar to web applications, some of them are not. Again, it's kind of a weird blend of web application testing, API testing, and device testing. All of the things that are in here are basically pass, fail, or not applicable, for the scoping or for the device or for what they've developed that you're testing. The things that are not applicable do not hurt your scoring at all on that spider graph, but it's really an impressive spider graph to give out. This is a view of the Excel file. You can download the MASVS and everything you need off of the OWASP website. There's a GitHub with all the information there. Again, this is what we're testing. You can kind of see the different testing topics and domains. You can see where they fit into the actual testing procedures through the MSTG, which we'll talk about in a second. And you can see statuses and links in the far right side to give you more information on how to test. And we just mentioned the MSTG. So we have the MASVS, which is what we're testing. The MSTG, not the MTSG, is the how we test. So it's yet another PDF file you can download from the OWASP Git repository that will show you several key things that you would be interested in. So it tells you where it is in the MSTG, and then it gives you an actual procedure that you can use to look and test. And then again, there's links in here also that generally point back to the MSTG. So a little more involved with trying to figure out what we're going after.
Okay, and if we're looking at the process of a mobile testing engagement from a project manager perspective, as you see on the right-hand side, you can step through each phase of this engagement. But really what I want to talk about is engaging the right types of people or the right entities on each side at each level. So in pre-sales, you might be talking about who's going to sign the contract, the people who are requesting the testing, getting those stakeholders on the phone. And then as you're moving into your testing, your weekly cadence of meetings, you're going to be coordinating between your testers and the software team or the developers. But it's always being aware of the conversations or the pieces that are coming out of testing that you're going to have to back up the ladder into those higher people. What do they need to know that's coming out of testing that may affect the scope and timeline of the project? And scheduling those meetings and keeping everybody on the same page, keep that communication flowing so we can get through our delivery in the agreed upon timeline. And this is pretty much what I just talked about, right? It's getting, as a project manager, you're interfacing with a lot of different people from a lot of different levels. And everybody needs to, they don't necessarily need to know everything all the time, but choosing what they need to know and getting that communication out among each group is really important, and keeping everybody on the same page and apprised of the knowledge throughout the project. That's why they always say project management is like herding cats. And it's definitely applicable when you're talking about mobile application testing. So
as far as, one of the big hurdles with getting these engagements and getting them set properly, if you haven't done them before, is of course your pre-contract scoping questionnaire. So we generally follow the penetration testing execution standard. You can go to their website; they've got some really good information on scoping and pre-contract engaging and how to fit things in a certain process. But with the mobile, there's nothing in there. And again, it's kind of a blend of web app, API testing, an actual desktop kind of testing, as well as, the actual device itself, which can vary. So some gotchas that we'd want to talk about, or, we may address here later, is that if you don't have a jailbroken iOS device, you're going to put yourself back a week or two into even testing this stuff out. And then, the other thing we hit sometimes is, as up to date as OWASP keeps these documents and the teams that develop them, there are more JavaScript languages coming out every week. We always say after the nuclear bomb, there will be nothing but cockroaches and JavaScript, right? So, what language they use to develop their code, if the code review is in scope, and you should if you can, can definitely throw a wrench if it's a language you're not used to, because most of the documentation refers to some very specific languages and how to test those languages. So there may be some learning curves for your team in the middle of this to do some research and convert languages you may not be familiar with into ones you can be more familiar with. Another other piece in there was how to test. Like most of these web apps or mobile apps are, again, parts that are an API, and they may be in a current CI/CD environment where you can't just go grab production and go beat it, because you could break something for all the end users. So, the same old adages apply to our normal web app testing: is where we're going to test and how we're going to test it. Try and get a sandbox from production, maybe a sandbox from dev. In some cases, the company may stop doing development until you're done testing. But these are all good points to work out and to think about before you even start. And one thing I don't think we've noted yet is there are some test applications that are out there, like the damn vulnerable web app for Android and iOS, that you can go play with to kind of get your hands dirty with before you actually do your first engagement. And from here, I think we go to Sam or John.
It is me. Hi guys, I'm John Adderholt. You saw me in those pictures there. I'm a relatively new addition to the team from a consultant perspective. I've been here just over a year. I come from a strong development background with C#, mostly .NET. Did that for close to a decade before making the switch over to security. So, so yeah, let's get going. So, mobile app testing is significantly different from, let's say, a network pen test or even a web application pen test. It certainly shares more in common with a web app pen test than it does a network pen test. And one of the unique things about this is you sort of have three areas of focus when you're performing a penetration testing against a mobile application. In the same way that a network pen test, sort of revolves around primarily, ports, protocols, and services, right? Mobile app testing revolves more around configuration, app permissions, and the source code, which can actually make it a more difficult problem to test them because you don't always have those with the background coding knowledge to do this testing. But it is, as you'll see as we move forward, it's an incredibly important phase of mobile app testing just by the very nature of how they are constructed, architected, and how they work. So yeah, Mark, if you go to the next slide, please. All right, so I'm gonna handle the Android part, and I want to just kind of go over some high-level stuff. We're not going to dive into the nitty-gritty necessarily of how the Android OS operates. That's a bit out of scope. But yeah, we're going to hit some high points that we really hope you guys can leave here today. And if you're curious about this, you have some kind of quick points and quick skills we're going to show you to quickly take a look at some mobile apps and see what you can find and figure out about them. All right, so the Android testing, you heard that Mark alluded a bit earlier about the remark about a jailbroken iOS device. Well, Android's a bit friendlier. It certainly does not require that. It is by far an easier platform to pen test. I think you guys have sort of heard it. Apple's sort of a walled garden, whereas Android, the OS, and a lot of it's open source. So, and they kind of install an app from anywhere. And also, most devices support rooting, and rooting is a really important aspect of pen testing, especially for an Android app, because that allows you to do some more things and take a look at a closer level at the file system of the device you're on, and what if anything that application is doing when it's interacting with the file system. And just a little small bit about the Android architecture. It uses kind of what's called a Dalvik VM, which is its kind of own way of sandboxing out applications from the core OS itself. For those of you with Androids, every single time you download an app, that app gets a brand new user ID created, and it's going to be numeric. And that's how they leverage that with the Linux user permissions framework to kind of help isolate the functionality and the behaviors of individual apps from, the kind of mission critical OS pieces themselves. And a hugely important aspect of, the Android ecosystem is the fact that you have the Google Play Store, where Google does a little more due diligence with the application verification and things of that nature. But you can absolutely go download just the app file itself from any third party anywhere on earth, be they trusted or not, and throw it on your phone for better or worse. So a very important aspect to consider when you're thinking about what kind of applications and potentially malicious code can even get to the device itself. Okay, some kind of your quick wins or quick looks, if you will, kind of in the Android world for pretty quickly determining some vulnerabilities are things that are really easy to quickly look at. Data storage. What is it using? Is it using Android's unique in that it has external memory that can be the SD cards and whatnot, whereas iPhones don't really have that. So the ability to get data off the phone is pretty easy. So how is it storing data? And next, the next big thing is what permissions from the device is it requesting? I don't know if any of you have, for whatever reason you would do this, go look at every single permission you as a mobile developer can request from someone's device, but it is a staggering amount of things that you can request permissions for. And some people, not everybody pays close attention to what's being selected, what's being asked for when you install that new app. So that's a very important thing to look at. And beyond that, especially with Android, the manifest analysis. Every Android application has this XML manifest that defines more or less everything it can do. What kind of data does it share? What permissions is it requesting? How is it going to interact, if at all, with any other applications? Can it, can it handle custom URIs like a telephone URI or a mail to URI, things of that nature? All things that are good to be aware of. It's in the way that it interacts with all the stuff around it within the operating system and on the device itself. Okay, it's a very simple and straightforward methodology generally for these engagements. First, step one, get the APK. Kind of our preferred method of doing that is asking the developer for it, and just please send us a prod build first. And as Mark also spoke about, we prefer them to at least generate a production build, but don't point it to production, please, so we don't potentially mess anything up there. If you can't do that, if they can't provide the APK themselves, there's a couple other ways you can do it. And this is where, my comment about, Android rooting becomes important. Is at that point, then you can root your device, and most devices support rooting rather simply. And then leverage the Android debugger, which comes with Android Studio, to then get command line access to the device itself, and you can upload and offload whatever you want from there. The last and least preferred means of obtaining that is building from source. I've tried this on a few engagements, and let me just say, I don't, my machine is not set up like an Android developer all the time. I don't necessarily have all the third-party dependencies, the proper SDK versions and things of that nature to make a build successful from source code. So if you can at all avoid building it from source yourself, it's a pain. And then kind of one of the last things, if you want to, is a bit of app disassembly. And now if that's in scope, that's usually pointing more towards the level 2 portion of the MASVS, but it is something you can do to kind of help your testing efforts. Okay, and a bit of common tools, and this is where, once you see the iOS part, you'll really see how this starts diverging. Android and iOS sort of diverge from each other in the simplicity. For level 1 engagements of the MASVS, you generally will not need anything more than Android Studio and MobSF, which we will speak about a bit later, but it's just kind of spoiler alert, it's a security framework that allows for some automated testing. And if you are, you can use these other tools I've listed beneath level 2 if you'd like as part of level 1, but they're not necessarily required. Kind of the big things here is the dex to jar is, Mark talked a bit about the source code, knowing which source code it is. We've seen, I think at this point, we've seen 3 different source codes for an Android app, just for example. And if you're, Android's typically written in Java, but it does support TypeScript, it supports Kotlin, and I believe even C# with Xamarin. So if you're more familiar in the Java world, your dex to jar is going to be able to disassemble your Android application into Java, which can be a lot friendlier, especially if you end up with an application source code in a language you don't really feel comfortable with. You can always sort of disassemble it back to maybe Java if you are more familiar with that. And just the other tools listed there kind of all go towards that disassembly.
John, and what is the difference between level 1 and level 2 testing?
The biggest thing is level 2 focuses a great deal on reverse engineering capabilities, and especially it's one you would want to consider if you're handling very, very secretive information. One thing, if you're doing any banking related information, things like that, that's potentially, because it's going to look more closely at the data you're handling and the nature of that data. It goes kind of beyond architecture and some basic code settings, but it's also heavily focused on how easily can I reverse engineer this application, and it goes into code obfuscation and things of that nature. But it's certainly, we haven't. Level 2 engagements are less common just because they're far, far, far more intense, and we generally just stick to level 1. But level 1 covers a massive amount of good points for any application developers. All right, now I'll hand it over to Sam Danna at this point.
Great, can everyone hear me? Guess no one else has their mic on, so I'll just go ahead and start talking a little bit where John left off to speak more on the iOS testing side. So this is by no means a specific methodology that you have to use to test iOS applications. It's just from our experiences over the past year. And I think there was a comment in the chat earlier about how it's almost pointless to publish, physical hard copy of something that describes how to test mobile applications, because it just changes so quickly. And in our experiences, we found that it's definitely difficult to find solid resources, that are relevant and up to date for iOS testing. And a lot of that's just because Apple is kind of ahead of the game when it comes to prioritizing security and changing their configuration. So as my colleagues have stated before, this is presented more or less as a collection of just some basic tips, tools, and lessons learned, using the mobile security project as your framework. And we definitely believe that the MASVS document can not only be leveraged, externally with third parties, like us testing applications from developers, but it could be something that's leveraged, by the actual development teams to advance security initiatives. So we're all familiar, at least most of us here probably are, with the ASVS, the Application Security Verification Standard. The MASVS is a very similar document that's a pretty good resource for just checking some basic security controls for your mobile application. There's not a real need to be a pen tester. In fact, I think that it's probably more helpful to look at an iOS pen test or security engagement more like an audit just of security configurations than just a pen test. And just like with any other pen test, no two are the same. And we definitely found that to be true over the last year of testing iOS and Android applications, that all were pretty significantly different from one another, focused on delivering, different things to the end user. Next slide, Mark. Yeah, so there are a lot of challenges with testing on iOS. The first is, most obvious is probably that iOS is not open source, and the security features they rely on proven cryptography, unlike Android. Architecturally, the security in iOS is baked in at pretty much every level, especially at the lowest level. So if you look at the graph, you can see that every piece requires trust from its immediate predecessor. So at the very bottom of the stack, or the first building block in the architecture, that has to be trusted. If there even exists like a any sort of breakage in that, the whole thing is just doesn't work. And now with iOS, there even exists a physically separate processor, as you can see there, called the Secure Enclave, which after the release of, I think it was the A7 processor, it has its own independent secure boot process that is permanently installed by Apple, and it can't be altered once the device is manufactured. So from that, the boot code also contains the Apple root CA public key, which verifies that the software loaded comes from Apple. And with this PKI, we're forming basically the foundations of a trusted bootstrap. So the integrity of every subsequent piece of code is also being vetted. Aside from architecture, the other challenge with Apple is that they tightly control their app store. John called it the walled garden, and it absolutely is every sense of that word. It's very difficult, if not impossible, to sideload any apps without jailbreaking. And as I just mentioned, every piece of software Apple wants them to have either written or vetted to run on an iOS device. And lastly, the other unique challenge for iOS testers is just the speed with which iOS evolves with regard to security. So there's a lot of really good articles that are written out there that you can find, just simply by looking at what others have done for testing iOS applications. And it's quickly outdated, and it's really frustrating to find good guidance and things if you're new to this, or you're just looking for some different points of view and different perspectives. Next slide, please. So the biggest thing when starting out with iOS testing is jailbreaking the device. So this has to begin before you even really start your testing, and there isn't really a good way to test an application thoroughly without the ability to break the Apple ecosystem. So we absolutely have to get this right up front in order to get all of our tools working. And I would probably say you kind of have to learn how to hack before you can even pen test, just to get your own environment set up correctly. It's definitely recommended to keep your testing device, whether that be an iPad or iPhone, running an older OS, just because it would be much easier to find a jailbreak. And definitely keep automatic updates turned off. We actually had this happen to us where you know, one of the iPads, not sure how it happened, but it updated itself, and I lost the jailbreak and lost a lot of stuff I had on there. So we had to do some searching and go to Plan B to get caught up on one of the engagements, and it was pretty frustrating. So lessons learned there. But the term jailbreaking is kind of it kind of sounds sexy, right? Jailbreak the device, but it's really just, you know, removing the restrictions that Apple puts in place. And there are three ways to perform that. There's tethered, semi-tethered, and untethered. And the you know, the tethered approach is temporary, has to be connected to the computer at every restart. Semi-tethered kind of permits, I would say, sort of a hybrid model, permits the, you know, the handset to complete a boot cycle after it's being pwned, and the extensions, you know, aren't going to load until a computer-based jailbreak is deployed over the physical cable. The untethered jailbreaks are much harder to come by, and they're more permanent. And usually the device only needs to get jailbroken once. But why, other than breaking the ecosystem, would we need to jailbreak the iOS device? Well, the biggest thing for us as pen testers, or, you know, security practitioners, is that it gives us access to the Cydia App Store, which is the unofficial app store where repositories, mods, other jailbreak apps can be downloaded straight to the iOS device. And it also allows for developers to use all of the APIs available in iOS, and the ability to display things like active processes, network traffic, modify files and folders. And that's, of course, pretty important stuff when you're performing any sort of security assessment in iOS. So I would argue that this is probably one of the more difficult things to learn if you're completely new to jailbreaking devices. And you know, one of the easiest ways to kind of learn how to do that is just pick up an old iPad or something. You know, don't do anything sensitive on it from, you know, an old friend or pawn store or wherever you feel comfortable with, and just, you know, try and run some different jailbreaks, because you're going to need kind of an older device to really consistently be able to do so. The one that we used was called Checkbrain. So huge shout out to our resident Fig, Cam Snell, who's our resident jailbreaker as well, and he was instrumental in kind of teaching me some of the things for you know, doing the semi-tethered jailbreak approach. And we kind of stuck with that throughout most of our engagements, and it worked pretty well. Next slide, please, Mark. So another just simple methodology, kind of in line with what John was describing for the Android, is you know, once you have the jailbroken device and an app to test, you know, aside from just looking at the basic functionality on your iPhone or iPad, before testing, it's pretty critical, especially when using the MASVS as a testing framework, to obtain or extract the IPA from the app. So the IPA is just the iOS App Store package, and the file is an iOS archive which stores the app itself. And it contains a lot of information, you know, needed for static analysis, and just, you know, just other things to go look at. So if the developer doesn't give it to you during scoping, or if there's, you know, not an easy way for you to obtain that, you can get it manually, but it is a little bit more work. And provided a little link down at the bottom of the slide. It's just a pretty good article written by Lucidius at Medium that just kind of shows, you know, the manual steps that you would need to take to pull the IPA from the device. So you will need some tools for that, though. You're going to need to install OpenSSH on the device so that you can more easily push and pull files off of there. And it's pretty common to find iOS guidance that tells you to use iTunes. But for most of us that are familiar with Apple and their products, iTunes was discontinued back in 2019 and replaced with Apple Music. And you know, this was kind of the way that you could easily obtain the IPA file before. But no longer is the case. And you know, even before they replaced iTunes with Apple Music, I think that they just completely removed the iOS App Store from it. So you have to go back quite a ways in order for that to be something relevant.
Yeah, I think
next slide.
That's a funny, because had we given these same slides a year ago, some of the tooling would be completely different that we would have recommended, right? So
yeah, absolutely. Go to the next slide. Thanks. So just some quick looks, quick wins, as we call them. The first things, once you have the jailbroken device that you can kind of look at it, especially if you have your MacBook set up, is you can go look at the network traffic, the authentication, session management, and plist files pretty easily. So the plist or property lists are, just an information property list that's structured XML, and it contains essential configuration information for the bundled executable, so the iOS app. And this can help just get a quick view inside the application to see if anything looks out of place. And the tool that we're going to demo here shortly, we used for static analysis, and it was really useful in quickly identifying property lists in use for the applications that we were looking at. And the reason also that this is important too, to look at the plist and something that I think you should take a quick look at is because developers sometimes utilize plist as a persistence mechanism which can lead to some unwanted sensitive information storage. This appears to be changing just from what I've been reading in the last year, 2 years, but it's still something to go look at that might lead to some findings. So once we kind of look at that and stuff, we have burp fired up on our MacBooks and the correct configurations on our iOS device, and we can essentially start walking the app and start proxying our traffic, looking at authentication mechanisms and traffic to the endpoints in scope. And with that, we can actually answer a lot of the questions and checklist items relating to network communication and session management on the MASVS checklist. So just some low-hanging fruit to go after quickly, and we'll make the test feel quite less complicated. There's a few things that require a little more manual work, like dumping the keychain and getting into all the platform interactions that we can leave for later on in the test once we kind of have the bulk of testing completed. Next slide, please, Mark. So common tools. This is by no means the default tool list, or just even all the tools that are available out there for you to use if you want to test an iOS app. But that being said, these are all the tools that I touched at one point or another over the last year and a half in testing iOS applications. So you won't need all of these, as I mentioned, but it can certainly make things easier if you already have kind of your environment set up and you have these things, in your MacBook and your iOS device. And I'm not going to go into detail on all of these, but one tool that I wanted to, that I thought was worth mentioning a little bit more about is OTool, which is just it's a great free and useful tool when testing iOS applications. And it's more of a developer tool that's used to show info about libraries, files, and other metadata. And it's actually a part of Xcode command line tools. And you can just get a lot of information out of it really quickly. And it's pretty easy to set up. So that's another way to get a quick win from from some of the things you can grab quickly out there. Let's go to the next slide, Mark. So as we've talked about a couple times throughout the presentation, this is one of the best tools that we found for an automated all-in-one kind of mobile application assessment framework. So huge shout out to these guys, the project developers at MobSF. It's makes the static analysis incredibly fast and simple for both platforms. And they actually have some cool e-learning courses and certs to kind of aid you as you progress through your mobile application testing phase or career. And it's super easy to set up. As you can see, it's ran locally and it comes with a web interface. And for Apple, you just simply take the IPA file or iOS zip file, as we previously talked about, and just drop it into the web GUI for analysis. And it will look at the binary file, the actual application, the images, the config files, and other things when you drop it in there. And you might find some more valuable information, such as other XML files, SQL stores, and other things. Next slide, Mark. And this is kind of what the output looks like for an iOS IPA file. So you get, after the analysis is complete, it will score the application from 0 to 100. And it provides you, with the associated risk for each of the things it's specifically looking at. So, there's some other outputs here showing kind of what the binary and binary code analysis looks like, the application permissions. And one really awesome feature that I loved about it was how it maps the standards. As you can see under the binary code analysis, not only does it provide like the CVSS version 2, but it also ties into the MASVS and MSTG, which I thought was really useful as we, kind of learn more about how to make this process more efficient. So, but with that being said, John, I'm going to kick it back over to you, and you can give the live demo.
Awesome, great, thanks, Sam. Let me see if I can share my screen here.
So while John's switching over, Sam, how much of the MobSF that works with Android and iOS, how much of that work does that help you with? It's like 30%, 40%?
Yeah, if I had to put an exact percentage, probably close to there. As I mentioned, we're doing more or less a security audit with a lot of these checklist items, and this can quickly knock out, at least a good quarter of them right off the bat. And if not, it's going to be able to point you probably in a good direction to go look more at some other things that may look interesting.
Yeah, can everyone hear me?
Sure can, John.
All right, perfect. Yeah, and I would agree, Sam, with what you're saying. Yeah, it's, like we said, this is more of an audit really than a pen test. And we have cases where MobSF can kind of help us with 50% of it, and then the remaining 50% is just all like kind of code audits and looking at some things there. So it really does help us knock out a great chunk of work and really find out some good information. So if everyone can see my Ubuntu VM here, we'll go ahead. I for the sake of this demo, I've just downloaded a purposely vulnerable Android APK file, just so we know we have some good findings in there. And I've already cloned the MobSF code and such from GitHub, and you should quickly run a setup shell script, and then just to run it, you do this here. And it's already going. It's a really quick, fast, and speedy app, and honestly, is one of the things I was most impressed with about it. Outside of its own results, was just how quickly you can get those results. And then we go to the one the endpoint we've defined when we started it. Now you can drag and drop your APK file in here. You can manually upload if you want. It's very fast, but in the interest of time, I've already uploaded this and had it run its scan. You'll just see a little progress bar, and then it'll pop over to the report page, and this is one of its strong suits. So you get this full interactive web page with all the information that it found, with shortcuts over here on the left, a general security score. And oddly enough, I don't know why they represent it this way, the higher that security score, the more insecure it is. So this is literally the worst possible score you can have, as opposed to 0, which is an interesting way of going about it, but whatever. So part of this, I want to show you just some of the quick things that it can kind of look at, and it even enables you to disassemble the actual Java code or Smalley code, which is sort of an intermediate step of code that Android can use. But what we're going to do here is, now that we've kind of gone through this exercise, so we get information about the signer. It looks at all the permissions. So a lot of this is, that manifest I was talking about is doing a pretty thorough analysis on it, and you can see it's accessing the course location, network state, and this is, you see it normal next to this one versus dangerous. A lot of these statuses sort of revolve around danger to the user, not danger to the app itself, if that sort of makes sense. So it's calling out things like, you need to make sure you need these permissions. Do you really need their course location, because it's sort of a privacy thing? Do you really need to get their accounts? Internet access, kind of normal. Do you need to read their contacts profile, et cetera, et cetera? So these are all things, and why it's such a collaborative process with the development teams is because you may not know necessarily, just from looking at the app, like, does it really need this? So it's genuinely a conversation with the dev team, the product team, everyone involved, to really determine if it's worth taking on this risk. Okay, so one thing I wanted to do is just let me stop sharing this bit of it real quick. As I wanted to kind of go through some of these findings and just do a quick little exercise of kind of, mapping them to the MASVS. So if everyone can see my whole screen, I hope that's not too small. I'm kind of working with a little bit of space here. And let me move that. Okay. So I won't bore you all and make us all go through this line by line, but I've kind of already picked out some things you can kind of see, and hopefully this kind of helps you see how the mapping sort of works. So the first one I wanted to start with was no sensitive data should be stored outside of the app container system or system credential storage facilities. So this is a big one because, obviously writing any data to anything should be a very intentful and thought out process. And, we see down here, it's requesting permission, and this is supposed to be a banking app, quote unquote, right? So it's requesting external storage access, and I can't think of a whole lot of good reasons a banking app would need to write my data to external storage. And one of the big reasons why is external storage on an Android device is readable by every single application on the device. So you could have a malicious app that goes on there and its entire job is just to look at the SD card storage and pull everything off of it and upload it somewhere. So real easy data exfiltration. So it's incredibly important to be very cognizant when writing to external storage. So, for the sake of this one, this bank app doesn't need it. That's a fail. And then that graph that we saw in some of the earlier slides automatically updates. It's a really nice spreadsheet that makes this really, really flow well. And the next one I wanted us to look at was the no sensitive data is exposed via inter-process communication, right? So is it exposing anything internally, that you don't need something else to be able to see? And so that's where we look at this it's more manifest analysis again, like that one manifest is so huge in determining what's going on. And this one right here, post login, and this one also do transfer. And these are activities, and not to go too deep into the weeds in Android, but an activity is sort of some functionality that the user can do and generally requires their interaction. It could be popping up a little login box. It could be confirming, sending a message. It could be anything kind of like that. And if these things aren't filtered appropriately in your configuration, any other application potentially on the device, if they know about it, if they know about this activity, can call it and instantiate it themselves. And an app, feasibly a malicious app that knows that this app is on your phone or is just guessing, could technically circumvent the login process by instantiating and calling this activity themselves. So it's a very, very huge issue, and activities and what they do are such a huge part of Android. So, from that perspective, that's absolutely a fail. Right, and then we just have a few more real fast, and we're going to go down to a different section. And this, I talked about how permissions are so huge and only requesting what's necessary. And in the context of this app, we're saying the bank doesn't need to write to external storage. Well, it absolutely failed this one, 100%. It only requests the minimum set of permissions necessary. Well, that is absolutely not the case. Why would it? It doesn't need to send SMS, things of that nature. But for the sake of this, definitely didn't need that. That's a big fail. And then just kind of the last ones, and this is a huge one too, because we've seen this before, and it's just kind of a forgetful thing, or it's just the build process itself wasn't right or configured correctly, and that's having debug enabled. Now that makes reverse engineering child's play to an extent. And this whole section, section 7 of the MASVS is all kind of about what are you doing with your code, how are you protecting it. And how are you doing things like that? And you see, they have 3 line items, 3 line items, are completely around debug version of the build and getting rid of that. So did you have a release build? Well, no, I didn't. Have the symbols been removed? Nope, they haven't, because it's a debug build. And likewise with the debugging code. So that's going to point more towards logging, things of that nature. But in this one, we don't really have any feedback necessarily to know that. That's where kind of the code review sort of comes in. But debugging and removing anything around debugging is such a huge part of the reverse engineering process. So yeah, that's basically it. There's a few more things in here. Some of this is a little more in the weeds, I think, than the scope of this presentation. But we're kind of looking to show some of the big wins and this manifest analysis, some of these quick things it came back with, and some of those things allowed us to just in a couple of minutes fill out 5-6 items on the MASVS. If we dig a little deeper, we can continue filling out more and more. And with that, I will stop sharing my screen. And I guess, Mark, if you want to bring the PowerPoint back up, we can wrap things up.
Sure can. Can everyone see my screen?
Mm-hmm.
All right, so I think we moved past this, and here we are.
All right, great. Thanks, Mark. And Sam, all in this part, feel free to chime in. I know it's kind of a collaborative thing and from our experiences. But, we wanted to kind of talk about some lessons learned in this process, and we'll kind of quickly go through this. And one thing I really wanted to highlight is, you've seen hopefully you've kind of started to get an understanding of just how much more difficult iOS can be than Android. So maybe like you've thought to yourself, well, hopefully not, but it wouldn't be totally unreasonable to think like, well, why don't I just have them test my Android version of the same one? And now, especially, with some of these new dev models that allow the exact same code base to be built for both, you think, well, why not just, I'll hand my Android version, they can do a little more, a deeper dive into it a little more easily. It'll save them some time, maybe save me some money. Well, a secure APK does not in any way equal a secure IPA or Apple, iOS app. One thing we kind of learned through this process, and it was kind of an interesting gotcha, is defaults aren't the same across, even if you use the same coding language, a lot of the default settings aren't necessarily the same across Android and iOS. One we saw in our last engagement, actually, that was kind of interesting is, securing web views inside the applications is pretty important, as it's a way to, literally just bring in the browser's capability and just a little simplistic view inside your app. You can run your whole app with just that. And all you have to do is, deal with HTML and web code instead of Java and whatever the iOS ones are, Objective-C and whatnot, and Swift.
Hey, John,
but because of that,
we got studying about 7 minutes left. So if we want to kind of get through this, if we can have any question periods.
Oh, yeah. I'll leave time for questions. Yeah, sure. But basically, one configuration was true on the iOS side, but it was false on the Android side, and by default. So you literally kind of have to look at it different ways. So keeping that in mind, configurations aren't necessarily always the same. So you really need to do the due diligence on both of them. And Sam, if you want to hit these next two real fast.
Yeah, so as I said before, just finding current information is a little bit more difficult to find than any sort of traditional network pen test or web app pen test for iOS. And I think that if it's useful to go into any engagement with kind of that open mind, it's really important to just not make the assumption either that you're going to be able to find everything quickly and easily, and that even if you do find something that's seems like it's in line with what the current test scoping is, it may not even be relevant anymore. So, and then, as we've kind of alluded to throughout this, presentation, that it's more or less a security audit than a pen test. So, I think that, that's just worth kind of highlighting once again, because, the MASVS is a really great document for, guiding testing efforts. And, it's extremely relevant with, the ubiquity of mobile apps and how fast that sector of technology is growing. And so, the more we have out there that are capable of properly, vetting and understanding the security behind these applications, I think the better. And OWASP does a great job of keeping that document up to date, more so than any other, resources that we've found out there. So,
yeah, Sam, I don't think we even went into like testing out the APIs, which is a whole other section in here. With authentication and authorization using Postman or other tools. So, yeah, this has been a good presentation for the device auditing for sure.
Yeah. And one quick last little point I wanted to make, bringing to get the most value out of this, for your clients, especially to help them the most, go through it's valuable for us to go through this on the security side the first time. But one thing we always recommend after we deliver our findings is to integrate the MASVS fully into your SDLC. This now becomes a checklist, a metric, a guide for you to help secure your app where applicable. So we always recommend that now that we've done this part, we want you to bring it into your process. You'll get not infinitely, but you will get way more value, because some of the questions in there, just, to be answered correctly, require an intimate knowledge of the code, the architecture, and all those things involved.
Right. I think at this point in time, we can do maybe a couple questions, or maybe we're over our time. Kyle?
Yeah, folks, feel free to unmute yourself if you have questions to ask these folks, because it's been really impressive. The MobSF program was really interesting to see the audit abilities of it from my perspective. So if anybody got any questions, feel free to unmute and ask.
Thank you, everybody. Appreciate it.
Yeah, like I said,
Yeah,
guys.
I guess one silly
go ahead.
question is, as an end user, what do you believe it's safer to use? Will that be the iOS, or would you stick to Android?
I'll take a quick stab at that. I would, and just to keep it simple, I would argue. Not, I mean, I'm more of an app. I'm not a fanboy, but I do have an Apple phone, an iPhone. I would say, just due to the nature of Apple's vetting of the software that's in their app store and their tight control and grip on the app store, there's less. I would give my mother an iPhone before I'd give her an Android device, for if that helps at all. It's just the attack surface is just a tiny bit smaller, just kind of by how they control things.
Okay, no, your answer goes.
Yeah, I would say that's John putting on his blue team hat, trying to protect his mom. From a red team pen testing perspective, hand everybody an Android, right?
Okay, because it's easier to be taken.
That's correct. Yeah, to make a lot of exploits happen, you have to write a malicious app to get onto the phone itself, and as we've seen, that's much trickier to do on iOS, especially if you have to have it vetted by Apple. They're going to quickly find out that you're doing something you shouldn't be.
Thank you for answering my question.
Absolutely.
Anybody else? I know we're about to come to the top of the hour, but anybody else? If not, once again, I'd like to thank these four folks for doing the great presentation.
Thank you for sharing with us. And my question is, you're mentioning that in this slide that what you showed us wasn't really steps for a thorough pen test, but more of an audit, with which I totally agree. So what would be other steps or tasks that you would carry on to perform a more thorough pen test of a mobile app?
Sam, you want to talk about the web proxy stuff? I know you did a lot of that.
Yeah, so just real quick, I mean, when we look at a web application, and we're using tools like Burp or Zap, a big component for, that port sort of testing, especially if there's an authentication component, is looking at kind of how those sessions are managed, what the session entropy is, if it's using, relied upon technology. And so that would be something that's a little more involved on the, the Burp or Zap side of things, looking at that traffic, using some of the tools that Burp has, like Sequencer, to test for session entropy, and just kind of looking more manually at some of the things on that end as you kind of use the app and you're capturing all that traffic. That's not going to be something that's, specifically, a checklist item in the MASVS. Of course, they're prompting everyone that's looking at a mobile app to look at the network communication. But those are the kind of, I guess, more pen test tricks and tools of the trade that you'll kind of need to understand more to really kind of test, those other aspects of the mobile app. So hopefully that answers your question.
Yeah, I think it did. That's what I was thinking about. I was wondering if you guys had any particular tips on thorough pen testing of the mobile app themselves, the APK or IPA, versus the network part of it, which of course it's a huge and important part of any mobile app that uses internet, right?
Yeah, Martin, I would say a couple of things to that. One is, there is a web app here, right, that has an API. So, I believe there's API testing built into the MASVS as far as identity and authentication management. Or you could go back to the ASVS and go look at those pieces just for the web application portion as well, right? So you kind of got to be smart and scope this out. Some companies may want you to look at just the application and the source code and those types of things and where it's storing data. But to get a full view, you're going to want to get a hold of the API, you know, and get a hold of their architectural documentations, you know, and do a full round of testing. Like I said, it's kind of a beast between a device, a web app, and APIs, and a desktop app on an Android. So, you know, there's really three main things that you have to kind of balance, you know, in the testing.
Sounds good. Thank you very much.
And with that, we might wrap up the chapter reading for the month. If there's nothing else. All right, well, join us next month on April 27th, which I don't know the topic yet or who's speaking it, but hopefully we'll have another chapter meeting then. So it'll be at the end of the month, and have a good day, y'all.
Thank you, everybody.
Thanks.